My name is Chris Keller, K0SWE. I'm fairly new to the game. I've only been licensed for about 3.5 years, but I was also a radio technician back in the Army and have been enjoying getting back into this as a hobby now. And I'm very pleased to work on many aspects of the hobby, including Winlink here. So let's get this presentation going. And by the way, is my audio coming through okay?
Yeah, it sounds great.
Great, thank you. All right. So we're talking about Winlink tonight. This is me. I am a software engineer by profession, which is how I chose my vanity call, SWE, software engineer. I do coding professionally, and coding is how I give back to the hobby. And so I'll be talking a little bit about some of the coding, just very briefly, that goes into Winlink. But let's jump in. Probably if you've been around the hobby long enough, you've heard of Winlink, at least in the abstract. It's a way to send emails over amateur radio. It is similar, but not the same as the internet email system. The Winlink protocols are actually tailored to amateur radio because with the regular internet email system, there is a lot of extra cruft, a lot of extra fat that we are able to cut away in order to preserve our bandwidth on the amateur bands, which is important for us. So let's talk about how this all works. In a normal case, what you're actually doing is, you've got your digital capable station, and we'll go into more detail about what exactly that means. But you're connecting to some sort of gateway station that, these are run by amateurs all over the region, all over globally. You connect your digital station to their digital station, and in a normal case, usually they will connect you straight to the internet connection at their end to be able to exchange emails with other amateurs, or this also connects to the global, internet email system. So you can exchange emails with non-amateurs. Of course, that comes with caveats about, they should understand to keep their messages short and to keep their attachments small and to, obey the rules of the road for ham radio as far as, language used and non-commercial and so forth. But we're just exchanging emails here. So I'm connecting my station. I'm sending out emails that are stored in the internet until my friend on the other end is also able to connect through a gateway to the internet and able to pull that message down. So it's store and forward, or in amateur radio, we also care a lot about being non-centralized. We don't always want to use the internet. We can exchange emails peer-to-peer, in which case, we're connecting directly to each other and exchanging any messages that we have for each other. So why would you want to use Winlink emails? Of course, this is useful for all hams in any case for, exchanging personal information or weather updates. But really, who loves these email systems is emergency communications. It's extremely useful to have, a hard copy, formal message that is not going to get lost in translation when you're talking to a served agency and they need to know exactly which equipment they are ordering, how many hospital beds are still open, how many meals are needed at a certain checkpoint. These are important things that you don't want to leave to a verbal exchange if you can help it. And so formal voice traffic passing can help in these situations, but a lot of what these emergency managers, these served agencies, are used to dealing with is digital communications, emails. They like that it's written down in hard copy and it's not going to change. And so MCOM folks just love these Winlink emails. And, within Aries, we practice this a lot. Within Oxcom, this is used quite a bit. And it's good for other uses, but this is really the people who have embraced Winlink emails wholeheartedly. Winlink is not just one program that you could put on your computer. Winlink Express here is kind of the most common client. It's probably what 85% of people use. But really, there's a whole ecosystem here of client apps that you can put on your computer and exchange emails over this system. It's just like with Gmail or Outlook or Yahoo Mail. You can still exchange emails with other people, even if they're using a different service than you. So all of these programs talk Winlink and connect to the Winlink system. Many of these are installed programs for desktop computers. Winlink Express, as I said, is sort of the most common. It runs primarily on Windows. PAT is another option that we'll go into some detail here. This is an open source and free software package that I actually contribute to. It's cross-platform, so it works for Windows and Mac and Linux. And one of the niches that we find a lot of folks like to use it is with Raspberry Pi computers, those tiny single board computers. And so we'll talk more about PAT in a minute here. WOAD is an interesting one. This is an Android app that goes on your smartphone, and you can connect this through Bluetooth to a Mobilinked TNC, and you've got a very compact, very lightweight system for sending and receiving these Winlink emails. So it's a very interesting option as well. So we'll go into a little more detail on how these things are actually exchanged. I mentioned you need a digital capable amateur radio station. So, a lot of people are familiar with Packet, AX25. Packet radio is one of the ways that you can exchange Winlink emails. And that's still a very good way to exchange Winlink emails locally, VHF, UHF. But there are also many other transports. Oh, boy. One moment, please.
Somebody's in trouble.
Sorry about that. We had a little more excitement than I was expecting tonight. I don't know how much of that was audible, but the kids were eating their pizza wherever the heck they wanted instead of keeping it out of the dog's way. So hopefully that is fixed now. All right, where were we? Talking about transports and modes. Packet is one digital mode that you can use for exchanging Winlink emails. So if you have a Packet station, you have a Winlink capable station. But there are also other modes here that also work. RDOP and VARA are two modes that are completely software as far as the encoding and decoding. So these are programs that you run on your computer, and then in order to interface your radio to your computer, all you need is a sound card and a PTT line. And a lot of people have that with the Signal Link USB is a popular option for those. Or, there are lots of options that support RDOP and VARA. Pactor is another option that is a physical hardware box that you plug one end into your computer, one end into your radio, and all the encoding, decoding happens on the hardware box here. So there are many ways to accomplish this. You might ask very reasonably, why do we have all of these options? More options means, I have to make more choices that I don't necessarily know what I'm doing. They've all got pros and cons, and I'll talk about some of the pros and cons here with the different modes, the different transports that we have available. One of the first ones I should talk about is Telnet. This is just the internet, basically. It's, often the simplest and fastest way to transfer emails, but it's not super interesting to us because it's not RF. We like actually sending waves over the air and, on the ham bands and stuff. So we like talking about the other modes here. AX25 packet radio. This has been around for 40 plus years, I understand. I think it's older than I am. It's very mature, very stable. Lots of people using it. Lots of people have set up infrastructure like digipeaters over on mountaintops. Lots of hardware, lots of software that supports it. And so it's an excellent option if you're doing local UHF, VHF stuff. We'll talk about one of the other options for UHF, VHF is VARA FM. VARA is kind of the new kid on the block. It's only been around for a few years here, but it's got some advantages we'll talk about. RDOP is one of our HF options. It's free and open source, and it primarily runs over HF. Free and open source is really the best thing that you can say about RDOP. It's kind of slow. It's kind of not super reliable, but if you are one of the people who is super excited about free and open source and giving back to the community, then RDOP is a reasonable option there. VARA's new kid on the block. It's very fast, very reliable. It's a software package, so if you've got a sound card set up, you're ready to go. You can use VARA for free, either HF or FM. You can use it for free, but if you buy the license for like $55 or somewhere in that neighborhood, then you unlock the full speed, and it's a reasonable cost. It's worth doing, in my opinion. The last option here is Pactor, which I mentioned. That's the physical hardware box. It's very fast, very reliable, and relatively expensive. You can definitely drop $1,000 on one of these Pactor boxes. And you can find good deals on used boxes too. That's certainly within reason, but compared to all of the other options at our disposal, Pactor is certainly the most spendy. Here I've got a chart that talks about some of the speed comparisons that we have for HF modes. At the top here is this light blue line, which is Pactor 4. But I learned back in March that Pactor 4 is actually not approved by the FCC right now. Rarely you will get a waiver. For instance, at the last hurricane, what was it, Ian? U.S. amateurs working the hurricane were approved for Pactor 4. And so that was available to those folks at that time. The next line down here is actually VARA HF, one of the newcomers. This software package that you pay $50, $60 and you get the second best speed here, the best speed that is currently legal for the US. the next line down here is Pactor 3. So, this software package is actually outperforming dedicated hardware. That's pretty impressive to me. I find that very interesting, actually. And down here in last place is RDOP, which, if that's what floats your boat, then please feel free. But if you're looking for speed, there are better options. On the other end of the scale, we have this VHF UHF comparison. Up here at the top, this yellow line is VARA FM, and they had to put this graph in log scale because VARA FM is just so much faster than packet radio. It just blows it out of the water. It's more than an order of magnitude, more than 10x speed under good conditions, and even under bad conditions. This scale goes from the best condition over on the left over to worst condition on the right, and almost down into the noise. VARA FM beats packet radio in terms of speed. But you miss because VARA FM is newer. It's not as widely adopted. You miss out on all of the digipeaters that people have set up, and that can be. If you need digipeaters, then you probably still want to be able to use packet. Down here in green is a small protocol known as FX25, which tries to add some error correction, but it's not widely used because in almost every case it's slower than normal packet radio. And so, unless you're really interested in experimenting with forward error correction, there's not much reason to use FX25. So that was kind of a very fast, probably too fast overview of Winlink in general. Any questions at this point before I move on to talking about the PAT client in particular? All right. Well, let's move on to PAT then. PAT, as I mentioned, is one of our Winlink clients. It is free and open source. You can go to GitHub and see all of the code as it exists today. Make any modifications you want if that's your sort of thing. And we gladly accept code contributions. We accept tutorials. There's a particular ham on YouTube named Jason, KM4ACK. I think quite a few folks have heard of his tutorial videos, but he is a big fan of PAT for good reason. Jason is a big fan of the Raspberry Pi single board computers, and PAT is one of the best options for Winlink on a Raspberry Pi. PAT was started by a guy named Martin, LA5NTA. He's out of Norway. He named it after a children's cartoon called Postman Pat. I hadn't heard of this, but it's a claymation series about postman in Britain that delivers the mail. And he thought that was a nice, playful name for a mail client. If you're an Uber nerd, there's a command line interface for PAT. But what most people seem to like is our web interface. So you start the PAT program, and then you pop open a web browser, and you're able to use this feels just like a normal internet mail client. And we'll talk a little bit about how that works. So installing is pretty straightforward. We've got, executable installers for, as I said, Windows and Mac and Linux and Raspberry Pi. I'm not going to go through the entire process, but I'll at least mention that. At this point, why don't I deviate from the slides and just show you the real thing instead of showing you slides of it. So here in the command line, I just started pat HTTP to start the thing running. And this is pat itself. So you can see I've got emails that I received from folks. If I want to compose a message, I just write to and subject and message body. This feels just like Gmail or just like Yahoo Mail. So this is pretty straightforward. When I send an email here, Mark, you mind if I send you an email?
No problem, but it's in 0xRx.
Oh, how if I fix that? Yep.
There you go.
Okay. So I'll post it, and now it's in my outbox, and it's ready to go. As it happens, I'm in the midst of a move. So I've taken down all of my radio station, but I can still send this via Telnet, so it'll send over the internet. But let's say, for instance, that I had a radio hooked up, and I actually wanted to send this out over the radio. Well, I could select which transport, which mode I wanted. And I am a big fan of VAR HF. And tonight's probably a good time for 40 meters. So there's, Pat knows where I am because I had entered into the configuration file. I'm at Delta Mike Force 449. Geez, I'm getting rusty. Yeah, DM49. So it knows roughly how far I am from all of these RMS stations, all these radio mail gateways. And so I can connect W0VG, I can connect K0SWE. Pretty often I will go out to Texas, WA5 TED. Their station seems to be pretty reliable. And so it will fill in the target call sign here. I can select from different bandwidths if if one station or the other has, hardware restrictions that, it's got a crappy sound card on it, so I can only use 500 hertz. If I have this hooked up to my radio, if I have rig control, if I have cat control, then it will actually dial a frequency for me, and I can just hit connect, and hopefully in a minute or two, the email will be sent and I'll be good to go. Instead, I'm going to send this over Telnet, over the internet. And here goes the exchange. It's off. My outbox is cleared. And someday Mark might get back to me. But this is really pretty straightforward. It feels just like any other internet mail client. It feels just like I'm using Gmail or Yahoo. I can view my sent mails. I can set this up to check on a regular basis. So maybe every 30 minutes, I want my station to connect to the gateway again and see if I get any replies. That's pretty easy to set up with Pat. Jeff Irvin has a note about the door prize. So do check that out. So yeah, this is pretty easy. Now, I will compare this to, I said Winlink Express, the other email client, is used by like 85% of people, right? More people use, let me get the icon up here. More people use this option right here. It's installed and it's Windows only, but it's what everybody knows and loves. One of the advantages I think that Pat has is that because the user interface is just a web page, well, we can get multiple people using this web page. And like I said, this is something that emergency communicators, EMCOM folks really like. And so imagine you're sitting in an emergency operations center, an EOC, and someone's brought their laptop to do the Winlink side, but they're coming off their shift. They need to take their laptop with them. So all of a sudden, you've got to stop your operations on the Winlink side in order to set up a new laptop, or someone's got to leave their laptop behind, or you can only have one person at a desk trying to run the Winlink station because there's only the one seat. Only one person can view it at a time. This is where I think Pat has an advantage here, because you can buy inexpensive hardware like a Raspberry Pi and just leave it in the EOC, and then people connect to it through this web page. And it's a local secure web page, but you can have multiple people looking at the same information through that web page. So you can have your served agencies can type up their emails themselves right in the web browser. You can have the ham radio operators looking at the same information, the same inbox. A message comes in, everyone sees it pop up in the inbox. You can have one person running the actual connections if you want. So I think this paradigm of using a web interface for Winlink emails is going to become more and more powerful as time goes on, as people see the advantages in doing this. I will say Pat has some disadvantages at this point, since it's like, two of us that are regularly contributing code, plus, we get contributions from folks all the time. But since it's kind of just a small team of us that are working on this, we can't keep up with all the features that Winlink Express puts out. And so we just recently got Winlink forms put in so that you can fill in an ICS 213 form and send that to another party. But we don't have read receipts, which a lot of people like to use. When you receive an email, Winlink is supposed to put a message in the outbox saying, hey, I got this. Pat doesn't do that right now. So that's something that we need to add. So there's advantages and disadvantages to these different clients. All right, Chris, if you email station to station, does it involve the cloud? So let's go back to this visual here. If you're using this peer-to-peer connection, then there is no cloud, no internet involved whatsoever. The email is only stored on the sending station and the receiving station, and nobody else knows about it unless they heard it over the air. And so this is a good decentralized way to do things without having to, leverage the internet, without having to expose everything to everyone. Exactly. Other questions?
Chris, maybe explain how the Winlink servers are distributed throughout the world, and when you send a message to it, and how it gets distributed, and how someone would pick it up.
Sure. So we talked a little bit about this diagram where, usually you've got your station connecting to one of these gateway stations. These gateway stations are all over the place. Let me see if I can find the map of this real quick. Because it's really impressive how many hams have offered their stations up in order to serve the community here. Can I full screen this easily? Doesn't look like it. Let's do it this way. So this is just the Pactor mode. But if I change, for instance, to Packet AX25, these things are all over the place. We've got several here in the Denver area. Let's jump over to Vara FM. This has been gaining popularity, so there's quite a few stations here. Vara HF. If you're looking at an HF range, there are lots and lots of options that are within range of us here in Denver, and so when your station connects to one of these gateway stations, the gateway station is just acting as a relay. You're actually getting a direct connection into the cloud. And normally this is actually AWS, Amazon Web Services. And there's a cluster of like 10 of these cloud servers that run the entire internet connected side of the system. And so your messages are stored on one of these CMS systems, waiting for your other party to connect and retrieve their inbox. And so this is actually a really robust way to do store and forward messages like this. Michelle asked, you mentioned no one else but the recipient gets the message. How does it know who it's for? How do email addresses get determined? Well, email addresses in the Winlink system are basically just your call sign. Let me go back to the compose window here. I am sending this email to a particular call sign. I mentioned this also connects into the internet system, so I can put in my internet email address here, and that's valid. But if it's just a call sign like this, then that's special. It stays within the Winlink system. And so you can send this peer-to-peer, like you can check this box, and it will never go to the cloud. It will only be sent directly to the other station. I should say, when you're doing peer-to-peer like this, obviously both of these stations have to be on the air at the same time. One has to be just listening and the other has to be transmitting. You don't get the same store and forward capabilities that you do with the the infrastructure version of the system. Tom asks, I was looking up Vara HF modulation schemes, and it lists a whole batch, starting with FSK and then various levels of PSK up to 32 QAM. So what is the format negotiated or specific? So is the format negotiated or specific to a receiving gateway? So my knowledge of how Vara FM is implemented isn't perfect, but I believe this is actually negotiated per connection, and I believe that's, it starts out at a very fault-tolerant, it starts off at the lowest common denominator. It starts off with the slowest, most reliable modulation scheme, and then if it's, it tries to go a step up. If it started out with FSK, then it will try and move up a step to PSK that's a little bit faster. And if that's successful, then it will go up another step until it fails at one of those points and it can no longer go any faster due to band conditions. And I think this is renegotiated throughout the Vara connection. I don't know a ton, but that's my impression of how it works, because I've seen it, switching between the different modulation modes, and it's fascinating to watch it, try and pick the best fit for the band conditions. James asks, does the receiving station need to have transmit capability for email to be received station to station? Yes. Well, I'll say that with most of these transport modes, most of these are assured delivery. And so, these stations are going back and forth okay, I sent you a packet. Did you receive it? Yes, I received that packet. Okay, here's the next bunch. Did you get that? Yes, I got that part. Most of the protocols are, call and reply this way. I know for sure packet is that way, and I know for sure VARA is that way. I'm pretty sure RDOP is that way. I'm not aware of any transports that are, send and forget, as it were. But there's other digital messaging methods that do work that way. Off the top of my head is, I think PSK31 works that way, doesn't it? You're just sending it out and hoping that the receiver gets it. There's no acknowledgement coming back the other way. Off the top of my head, I don't remember exactly, but there are modes that work that way. I just don't think there are any Winlink modes that work that way. Hope that answers the question. Other questions? I brushed over a bunch of topics here. And I saved one kind of for the end. I'm sure a lot of people have set up digital capable stations before, but if you have not done this before, maybe you've got questions about how do you actually hook up all the cables, and we can talk a little bit about that if anyone's interested. There's many ways we could take the discussion.
I'll go ahead and drive it. Yeah, go ahead. Go for it.
Oh, go ahead and talk about setting this up. All right. It depends on, exactly which modes you want to work and, your particular radio and such. Usually, all you need is some sort of audio signal going into your radio and some sort of PTT signal. And so interface boxes, hang on a sec. What do you want, you mutt? Talking to my dog, not my kid. So usually, you need audio in and audio out and a PTT signal going between your computer and your radio. And so SignaLink USB is one of the most pervasive solutions. What? USB is one of the most common pervasive options. The thing about SignaLink USB is it does not speak any particular mode itself. It's just a sound card. And so you need some sort of program that is going to do the encoding and decoding. It's a very flexible option because you can use a program like Sound Modem or what's the other one? Direwolf. Those are programs that speak packet radio, and you feed that program into the sound card and send that out over the radio. There are other options for modes like Pactor. Pactor is typically done as a physical box. And so it has one cable that's probably USB that is going into your computer, and one cable that's, you probably have to build the cable, but it plugs directly into your radio. And so that's pretty foolproof. Other options like, there's, of course, what's the traditional packet modem? The
Cantronics.
Cantronics, thank you. Cantronics, it's got either a serial port or a USB on one end, plugged into the computer, got a cable that's built for your radio goes into the radio. And in that case, the actual encoding, decoding happens within the Cantronics box. Same thing with Pactor. So instead of sound being sent between the computer and the box, there's actual decoded text being sent between the computer and the box. So there's lots of ways to accomplish it, depending on which modes you're trying to use. But I'll write down some of the big options here. Another interesting one to mention is MobiLink, which is also a packet modem, does encoding and decoding inside. But this doesn't do a USB connection. It does a Bluetooth connection. So you can have a wireless connection between the computer and the TNC box. It's still got to be wired to the radio, but you can have some wireless separation there, which is kind of fun.
Chris, James has a question for you.
James, does PAPS contain pre-configurations for SDR radios that have built-in sound cards? To my knowledge, we don't have. That's a really interesting option. I've never played with a high-end SDR that can actually do transmit and receive. I would love to try that out, though. Yeah, I don't think we have any pre-configured options for that. Sorry to say. But if you want to work with me on trying to get one of those running, I am quite happy to experiment with that. That tickles my funny bones thinking about trying to do that.
Hey, Chris, let me just pop in here a second and tell everybody that Jeff has the drawing on the chat, the link. So, DRC members, welcome to go in there and put your name in. Thank you.
Yep. Yeah, if you're not entered for the door prize, now is an excellent time. Other questions? I hope there was something new for everybody here. Even if you'd heard of Winlink or used it before, I hope the PAT information was new and interesting and useful.
Thanks.
Really, any other questions at all?
How about a comment? I thank you for this. I did not realize that WinLink really was an application and a transport, and the two were separated. So I appreciate having that information. Thank you.
Absolutely.
Okay. Anybody else? Hearing none, I guess we'll thank you, Chris. Interesting, very interesting. WinLink, something that I personally would like to play with more. So it's an inspiration, I guess, to do something. So thank you very much. Anybody wants to get in the drawing? Where are we standing, Jeff?
13 responses so far.
13. Okay. Anybody hasn't got in that wants to? Hearing none, I guess go ahead and draw.
Stand by and I'll spin the.
Thanks very much for having me.
Enjoyed it. Yeah, very much.
Okay, it looks like our winner tonight is Dan Cook, AA0QC. Dan's got his hand raised.
Okay, Dan Cook.
And Dan's got his hand raised. Go ahead, Dan.
Okay. Alrighty. A0QC. Yeah, I don't. Okay, I see it
Maybe he's just raised in celebration.
in celebration. Okay. Well, congratulations, Dan. We'll get your. If you're good in the roster, we'll get that off to you probably by tomorrow. Is your address correct in our roster or in K0SWE? Yes. I don't see you here.
He says
Dan.
yes to both. He says yes to both.
Yes to both. Okay. Okay. Well, great. Well, congrats. Unless there's any other questions or comments or for me or Chris or anybody else, we'll call it an evening. Again, thanks very much, Chris, for taking the time to do this. Much appreciated. Very interesting. Okay. Well, hearing nothing else, we'll pull the plug and see you at the next event. 7-3.
See everybody.
That's